So when we're working with our problems in engineering, and even in a lot of our science classes, for the most part, the numbers that we use, the values that we get, the models that we're going to end up using aren't going to be perfect. They're not going to give us perfectly precise and accurate values. They're all going to be close, but not the exact number that we'd be getting in math class. So here's an example. If I measure the distance from my front door to my mailbox, I'd say it's about 100 feet. Now, it's not actually 100 feet. It might be close to that. So then I go and I find a measuring tape that measures in feet, and I go and measure, and I say, it says 97 feet. Well, it's technically not 97 feet either. My tape measure wasn't very accurate. So I get a more accurate tape measure. This one would include inches. And I go measure it again, and I get 97 feet and 2 inches. Again, this isn't perfectly accurate or precise because, well, maybe there's fractions of an inch. Maybe there's billionths of an inch in there somewhere. Maybe there's some slack in the measuring device. Maybe it's not perfectly calibrated. There's all these little things that might show that I'm not being exactly precise and accurate. If I spent a lot of money and a lot of time and practiced a lot, I could get a value that's very, 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 very accurate, but not perfectly accurate. If I were to somehow figure out to the atom how far something is away, how far my door is from my mailbox, I'm still not done because the wind's going to blow and the earth vibrates a little bit. And as that happens, that distance isn't going to be exactly the same to the atom constantly. And so every answer that we're going to give and every measurement we're going to make is not going to be 100% perfect or precise. So we use what's called significant figures to tell somebody the precision that we know an answer to. So if I have the number 12, technically I have a whole bunch of zeros in front of it because I have 0 hundreds and I have 0 thousands and 10,000s and 100,000s and millions and billions. I have zeros all the way through there. But that's boring. I don't need to show that. It's not telling anybody any information. So what I could do is I could say, you know what, let's get rid of those. Those don't exist. All right, that's fine. I also want to fix a few other things. One reason we don't want to do that, there are actually two. One reason is it's just messy. It takes up a lot of space. It's hard to see the exact number. If I want to know that there is 12, I don't need that much space. I just have this whole line of numbers, and in it is a simple 12. It's just so much stuff there. The other thing is if there is that much stuff, it seems like you're giving me a lot more information than just the number 12. And so it shows me that there's maybe some precision going on there, that it's like, wow, this is a really accurate 12. And so first off, we can get rid of all of our leading zeros. They're not doing anything. The last thing we're going to want to do is we're going to get rid of all these other zeros, unless I actually know that it was measured to be 12.00000000 something. So if I was measuring something and I found out that it was 12 meters and I had a measuring stick that went to, nanometers or picometers, and I saw that it lined up to 12 meters and exactly 0 picometers or femtometers or any of those things, then I'd put those zeros there. But normally when I have the number 12 and I say something is 12 meters, it's more of an estimate saying, yeah, it's 12 meters. I measured it. It's pretty close to 12 meters. So we're going to talk about how to write those out. And when you see a number, trying to guess the precision that the person wants you to interpret it as having. All right, so the first thing that we want to do is we need to figure out which digits are significant in a number. So all numbers that aren't 0 are always significant. If it's not 0, it has a value, it has some meaning. So I have the number 42 here. Both of those are non-zero. So that means this number 42 has 2 significant figures in it. And so we write that by saying it has 2 sig figs. It's just easier to write sig figs and significant figures over and over and over. All right, so now if I look at the number 200, there's one non-zero number, that's the 2, and then I have these zeros. These zeros here would not be significant. They're just holding the place so that this 2 is in the hundreds spot. If I didn't have these 2 zeros here, well, then it would just be a 2. It would look like there's 2 of something instead of 200 of something. But I don't necessarily know that these zeros are accurate. Maybe the real value is 199, maybe it's 201, maybe it's 200.1. I really don't know the accuracy of it, so I can't necessarily say that they're significant. So instead, I just take the non-zero number and say I have one sig fig or significant figure. Now, to complicate things, sometimes zeros can be significant. So the first rule about when a zero is significant: if the zero is between two non-zero numbers. So in the case here of 103, this 1 is significant because it's not 0. This 3 is significant, it's not 0, which means if I measured something in the ones place, well, I have to know what's going on in the tens place. I can't measure something that's in the ones place without knowing something about the tens place if I've also measured the hundredths place. I have to know what's going on here, and in this case, there has to be 0 tens. It just has to be that way. So in this case, I actually have 3 significant figures. So that's the first one. Then we get into what if there's a decimal point. So if I have a non-zero number, like this 1, and I have a decimal point, I shouldn't write that decimal point unless I know for a fact that that decimal point lives there and is accurate to that spot. And so any numbers between my non-zero and my decimal point, when we're talking about large numbers, numbers above 1, things that aren't partial valued numbers, what I'm going to do is I'm going to include those zeros as well. So in this case, I have the 1, and I have these 2 zeros because I'm telling you that this decimal place is accurate. That's an accuracy setting point right there. So this also has 3 significant figures. So if we look at this here, this one's kind of a combination between the last two. I have non-zero number here, non-zero number here, which means the 0 in between is significant. So there's 3 significant figures. I also have a decimal point over here, which means that my non-zero numbers, my significant digits over here, and my decimal point here, everything in between these 2 things are significant. So this gives me 6 total. All right, so now let's talk about partial numbers, numbers that are less than 1, things that are fractions or bits of a number. So any leading zeros that are between the decimal point and my non-zero numbers, in this case, they're not considered significant. It's the mirror image of this 200 right here. I don't include the zeros between the decimal point and this. Now, you might say, well, you included them up here when the decimal point was there. This decimal point is just telling us that we're smaller than 1. It's not telling us anything significant. This 3 is just being told that we're in the 10,000s place. This is a tenths, this is a hundredths, 1,000, 10,000ths. These zeros are just pushing this into the 10,000ths position. So in this case, I only look from here on over, which would be 2 significant figures. Lastly, if I have trailing zeros of a partial number, of a number less than 1, they are significant. So I don't include these first 2 here. I include these 3, but I'm also going to include these last 3 here. So 6 sig figs. So in short, If a 0 is just holding a place, you can write the number 200. The zeros are just sitting there, so the 2 looks like a 200 and not just a 2. Those zeros are not significant. They're not telling me anything about the value in the ones in the 10th spot. If the zeros were measured and the actual value is 0, then I put the decimal point there, and it tells me that those are significant.